Cool. Hope you're all having a good afternoon here. We have an interesting time that we're living in right now with the web. And it's a lot of fun because we get to write code and play with a lot of cool new frameworks and try things out. But at the end of the day, eventually we have to ship our code. And shipping our code can mean a lot of different things. So taking something like Angular and Node, you can push it into some kind of cloud, or you can put it on an internal server. There's lots of places you can put it, but there's a lot of things we have to consider when we're building these kinds of applications. And this talk today is going to show you some of the ways that you can handle your code to make it run on the web and also to make it run better on the web. So we're going to start off with one of three angles. The first angle is how do we build Angular code, first of all. We'll start with the code itself, and then we'll look at how do we migrate it into the cloud. When we build our code, there's really cool tools with Angular like the Angular CLI. We can run the Angular CLI commands, and those commands run with this ng syntax. That's the Angular CLI. We can say, okay, let's generate a new component called customer, or generate a new service with customer data, or a class. We can generate a bunch of kinds of different files using the CLI, and it will connect everything up for me into the Angular application so it just runs. And this is what the Angular CLI and the Create React App CLIs do for us out of the box. But really, that's not the main value. We can all write code, we can all create files and save them and name them. That's easy. The harder part is actually creating a build process. Some of you may remember going through the processes like using Gulp or Grunt or Broccoli or some of these other tools that have been out there for a while. If you did that, you probably remember a lot of pain trying to make sure you get the sequence of the files into your pipeline in the right order, doing it the right way so you end up with a really nice output. The CLIs with Angular and React, they're going to help us build those kind of things much easier. So now we can just say ng build, and it's going to create a development build. Now what's a development build? The target audience for development build is me, the developer. It's you. We want the development builds to be something that are optimized for development. So I can write code, I can see it in the browser, I can make changes to the code, it recompiles and shows it right in the browser again, and I can rinse and repeat. The point of this is to be super fast locally on my dev machine. This is important because it's not the same as building something for a user. Our end users would like a production build. So we talk about development and production builds. They're not the same thing. They have completely different audiences. Production build is supposed to be fast and have a great user experience. A development build is for the developer to get things moving. One of the big differences here might be in a development build, I might have 20 meg of files going to the browser. Not a big deal locally because everything's on this laptop. But once I take this to the cloud, that becomes a big problem, especially if I'm on a mobile device or a slow internet connection. That's where our production builds can really kick in. And one thing Angular does is it gives us this build optimizer flag and a production flag. Let's take a look at kind of what those things will do. So in these different environments, first of all, in development versus prod, we can have an environment file that lets us set client-side environment settings so the builds will automatically look at which file that we designed for. We can also do cache busting. We'll turn cache busting on for our production build. What's that going to do? It's going to name all the files differently and uniquely so that when we push out new builds, nobody's caching the files in the browser. Again, for development, not so important. For production, it is. Source maps, we really don't want them in production. We can turn them on if we want, but by default, they're not there. Again, it's more overhead that we don't need in production, but it's great so I can do debugging locally. Extracting CSS, uglification, minification, bundling, and something called AOT. These three processes here allow us to shrink our code down, do code splitting and put them in separate files so we don't end up with 1,000 files. And AOT is unique to Angular. It's called ahead-of-time compilation. What it does is it pre-compiles all the Angular templates on the server at build time. The reason this is important is without this, let's think what will happen. If we don't compile the templates ahead of time on the server, we're now sending the Angular compile across the wire to the browser, and it has to happen at runtime every time a user hits a site in the browser. And can you guess what's faster or slower, the server or the browser on your mobile phone? Yeah, the server. So that's one thing that doesn't happen. And then the second thing is that by compiling it on the server, you're going to send less templates to the client. So we're sending less stuff to the client, and we don't have to process it on the client. So it's going to make things smaller and faster and lighter, but let's take a look at what that means. Now, all the demos that you're going to see today are actually in a GitHub repo that I'll share the link to towards the end of this, just so you can take a look at it. This is a simple application. It's called Angular Cosmos DB. It's just going to have a simple hello world. And what I've done here is I've set up an application so I can build it. We'll go over to terminal, and we'll go full screen for a minute. If I run through here and I type in ng build, oops, that's fascinating. Can't you imagine what you're seeing? Why are you seeing that? Hey, AV person. Hi. I'm going to try to do a little bit on-the-fly debugging, see what's going on. Do you see me now? All right. See, your mere presence on the stage solved all problems. Thank you. Don't leave. They can't see now. I'm kidding. Boy, that would be really mean. All right, so we're going to use a simple command here to build an application. I'm going to run ng build on the developer side. Make it a little bigger, too. What this is doing is building my local project for a development build. It's going to run through and it's going to create the files for me. And at the end, you're going to see a couple files. Inline bundle. So inline bundle is only 5K. I got really loud there. It's only 5K, and that file is basically going to be Webpack. It's starting up my project. It's a little bit of overhead that you give to the project to kind of start and kick things off. Then we've got main bundle. The main bundle is something I wrote. It's all of my code. So that's something I have direct control over. There's 31K there. Polyfills, there's 200K. That's quite a bit. And quite frankly, we can get rid of some of these if our browsers, if we know our target browsers, and we can reduce which polyfills we include. But it's still a little concerning it's that big. Let's see what we can do about that. Styles, 15K, and oh my, 2.3 meg for a vendor bundle. Vendor bundle is totally not in my control. This is third-party libraries that I'm using in my application. So we can see the total sets of build for development. A little bigger than I'd want for a real application. So I can run another step here by doing ng build prod. Now this is a production build. Let's see the difference that this build does. It's still going to end up with the same number of files, but now we're going to see a couple of differences, both in the size and in the naming of the files. First thing you may notice is that we get these cache-busted letters and numbers at the end of the file names. You'll also notice the polyfills shrunk from 200 to about 66K. So it did a lot of uglification, minification, and other processes to reduce the code. Main went from 31 to 18. Now 13K might not sound a lot, but I have a very small application. Imagine this app was huge. That's almost a 50% reduction right there. My vendor file went from 2.3 meg down to 300K. That's significant. We just cut a 2 meg off of our project size by going to a production build. But another thing that happens besides our apps, a lot of times we write code and we end up with code that's really not being used. It's called dead code. And there's a process called tree shaking, which can help go through our code, looking at our dependency chains ahead of time and shake out any dead code we're not using. And to enable this here, we can type in this really long command, which I never spell right, build optimizer. It's a experimental feature with this version of the CLI. In later days, it may just be baked in. But this is going to run a production build, but also do tree shaking. So let's see what happens in this case. We should still get all the same things we got with the production build, plus it should improve things. Let's see. First of all, you notice that there's only 4 files. The vendor file's gone. So at first you might think, oh yay, Angular just decided we didn't need third-party files anymore. That'd be kind of cool. But actually what it did is it combined the vendor files with main. The main file is now 268K. So if you do a little bit of math here, and I know it's not fun to do, 316K plus 18K, so we're looking at about 334, right? And we cut that down to about 268. So we're able to chop a little bit more off our app by reducing code that we're not actually using in the application. I have this little ongoing joke with the Angular team saying the more flags they add, eventually we'll get to a negative size file. So hopefully we can get there. But the cool thing is we're just doing simple automated processes to shrink down our file size. Something else we can do, if we go back and look at the code, let's go in here, and there we go. And you are seeing this, good. So in my code here, let's say I go over to my hero service. Notice that I'm adding in RxJS. All I'm using is catch and map. Well, you can imagine in a real application, I might use a lot more operators for RxJS. So it could get really kind of painful to go ahead and type these kind of commands in all over the place. So a very simple shortcut is say, you know what? I just want all of RxJS. How big could it possibly be? Well, if I rerun my process over here, and let's just run the prod build for now. And actually, I got a command for this. Let me go run it. Yes, ng build prod stats JSON. So let's run that one. I think that was what it was called, gen stats, yep. So this is going to run the ng build prod with this flag called stats JSON. Stats JSON is a way to tell the Angular build process to create a stats file for Webpack so I can analyze what's inside your project. So the output of the build will be the same, except we'll get an additional file called stats JSON. Notice we're back up a little bit in vendor. Vendor is 501K. If we go back 2 levels up, vendor was 316. Now, you just saw what I did. So the big reveal is gone. But imagine you've been working on this project with everybody in this room in a large app. You have no idea what people have included in the project. And more importantly, you don't know which imports and other features are actually needed versus not needed. So how would you go in and figure out, how can I reduce the size of this application without affecting it negatively? Well, one way you can do this is to use a tool called Webpack Bundle Analyzer, which is right there. And another one is you can run something called Source Map Explorer. There's a couple of these that are out there. So let's run gen report. Now this is going to look at that stats JSON file, and it's going to explore and explode up everything inside my project. The thing to look for in here is going to be, do you see anything on the screen that shows like millions of little tiny rectangles? If you see that, that's a good sign that you're probably pulling in a lot more than you actually need in your project. So by looking at that, I hover over RxJS, and it shows me here that that is actually 874K unzipped. That's a lot of code. And if I click on that, I can start diving in to see, okay, what's inside of there? Am I using all of these operators? And if I don't recognize a lot of these, that's a great place to start and look and say, you know what? I probably have a place here I could optimize. Let's go ahead and start reducing some of them. One of the nice things about this tool is if you hover to the left, you can also uncheck certain ones and just explore the vendor file if you want to. Or you can explore your own files. So you can click the ones on or off, and you can also look at the sizes based upon gzipped versus minified versus untouched. So this tool is very nice for taking a look at what we can do to optimize our code. So those are a few tips on figuring out how we can optimize the code. There's other things that we can do too by looking through our application. But once we get the app done, the next step is to take that code and to push it into the cloud. Here's some different tools we can look at, and the links are in the slides. But one of the things I think about before we get it into the cloud that often happens is I'm running a Mac on a certain version of Sierra with a certain version of Node and NPM and Angular and the Angular CLI. I've got a lot of versions hanging around here. What if you're using Windows? What if you're using Node 8 and you're using Node 7? How do you make sure it runs on my machine isn't the thing you hear when somebody's screaming at you because it doesn't work? You want to make sure it runs everywhere. So one of the ways we can do that is to use something called containers. The reason we look at containers in this case is because not only you have to worry about all your developers running the same thing, but you also have to worry about your CI/CD process running the same version, and how do you know what's in the cloud is running the same as well? So we want to basically go through the steps that the build process just did. Install our dependencies, our platforms, all of our Angular assets, our Node Express servers, and copy it all to a folder, and make sure that everything I have running locally is the same thing I have running in the cloud. Sounds easier than it is until we get to things like containers. So the way I'd like to go about this is let's take a look at what Docker containers do for us. Here's a sample Docker file. It's going to have a self-contained script. It's going to provide a recipe for creating this container that runs everywhere with our application. And it's going to configure different environments so that what runs locally runs differently in stage, test, and production. Now, you might have a file like this where you're pulling from Node 6.11. That's a common Node platform that's out there on Docker Hub. You pick which one you want. Now I know that's the version that we're using locally and in the cloud. I then define my working folders. I copy my package.json over. I then run npm install. I then copy the rest of my files, run my build process, and at the end, I expose my port, and I call Node.js to run my Node server. It's basically all the steps I would have to do locally. I've just written them down inside of a Docker file. So it knows, hey, this is what you do manually now. Go ahead and automate this. By doing this, we can automate this for local or for production. So reviewing the steps that we're going to do here, we're going to create the Docker file, we're going to build and run, then we're going to debug this locally. Why debug it locally? Because I don't trust anything that takes control away from me, and I hope you all don't either. So the thing about Docker that concerned me when I first heard it was, okay, great, I'm putting all my stuff in a container. That sounds like I can't get to it. Like I'm thinking Tupperware now. Once I put that food in the Tupperware, I can't get to it unless I take that lid off, right? Well, with the Docker container, there's ways we can actually tap into it. And the way I feel better about Docker is if I can get my app to run and I can check logs and I can debug it locally and I can do everything I could normally do just as if it wasn't in Docker on my local machine, and it does not disrupt my dev debug cycle, then I'm going to go for it. So let's take a look at how this works. All right. So back in the same project, I'm going to open up the Docker file because we're going to take a look at that. And I'll explain kind of how this is working here. But to get things working, I'm going to show a little script I wrote. There's a really cool extension for VS Code, by the way. It's called the Azure CLI extension. And the funny thing about it is I rarely use it for Azure. Even though I work for that team, I use it for writing bash scripts. What it allows me to do is I can write commands like this, like just ls, hit command, and then quote, and it runs down below in VS Code. So it allows me to save bash scripts in a file that I can then run locally. So one of the things I can do here is I could go and run docker compose. Let's let that run and show you what happens, and we'll go look at that file. So if we go over to my Docker file while that's building, let's make that go down. What I'm doing up here is I'm pulling down an image called John Papa Angular CLI. That's based upon the Node image I just showed you, but it also includes the CLI in it. And then I'm saying as Angular app. This is like a temporary container. I'm creating a temporary container here that's not going to live anywhere else. I'm using this so I can then run npm install and build my Angular app for production. It's then stored in Angular app. I then build my Express server, and I call that Express server. That's also temporary. It's called a multi-stage Docker file. And then, finally, I take my final image, and I say copy from the Express server and from the Angular app, put the two things together, expose my port, and run Node.js. And the output of this whole thing creates a container and an image. Let's take a look, now that it's done, using another extension for VS Code called Docker. Over here, you'll see a list of images. I can hit refresh, and you'll see the top one right there is the image I just created. And it also is running locally. That's what the little green light is. Don't believe me? Because I wouldn't either. You can right-click here and say Show Logs. And let's go back over here. And you can see there's the logs that are running, so we can actually see it running live. Let's do that again, just so you can see it. Show the logs. So anytime we hit the server live, we could then see it running. Let's check it out real quick. So up here, let's go back to the demo. And I can open the browser right from there. Oops, wrong window. There's my little app. And every time I open this app and I run it, if we go back to the logs, we should see that I made a call to Mongoose in there. So we can see the logs. What about the files, though? How do I know the files that I wanted are in there? Oops. I think I just clicked the wrong one. Uh-oh. Let's attach the shell. We'll go back down a little bit. If I want to make sure I know what's inside of Docker, I can do an ls. There's the files that I copied over from Node. I can also look inside the public server, and I can see these are the Angular files that I created. So I have a higher level of trust now that what I'm running locally is actually in that container, and I can get access to it. But what about debugging? Well, let's go ahead and rebuild this. I think I built it for debugging. If we look at the Docker compose file, you'll notice this Docker compose file basically just says run the Docker file, name the image this, set the node environment to development locally, which inside just opens up some development settings. And then one of the ports here I'm opening up is 9229. That's the default port for Node 6, I think it's 9 and higher, for debugging. So I'm allowing this debug port so I can then inspect Node. And then in VS Code, I'm going to go over and I'm going to debug by using this little bit of code here. I'm going to debug my Docker container so I can set breakpoints and run it locally. So I tell it to port, it's on localhost. I tell it I'm not using source maps in this case, and the important line is line 20. That's where do you want to map the files from the container to the files locally on your machine, so it can map the files and I can actually step through them. And then, once I hit run over here, I'm running through it. I should be able to come back here and notice I've got a breakpoint set, and I can walk right into my code, examine values, step over, step into, disconnect, do anything I want to do locally. Super simple. So I've lost zero control by running my Node and Angular app locally on my machine inside of Docker. Then I can disconnect and call it a day. So we've done two things so far. We've shown how we can build and optimize our code, and we've shown how we can run it locally inside this thing called Docker. And the commands that I ran were Docker compose, and I actually specified a specific Docker compose file, up. Up means go ahead and build the Docker container, and then inside there I also tagged it. But if I want to tag this for the public use, if I want to push this to Docker Hub, which is just a registry of images that we can all use, or I want to push it to a private registry of my own, or maybe Azure's container registry with login credentials, I can then tag that with the prefix of the name of the container registry and then the name of my image. And what that does, it means then if I do a Docker push, it'll take that Docker container locally and push it up into the cloud. So it just takes that image, pushes it up, and then whoever has access to that registry can then create new instances of my app, one or more, if you want to do load balancing and scaling. It's kind of cool. Puts everything together for you. In this case, I'm pushing up to the Azure Container Registry. But I still didn't solve the problem of it still requires me to create this image and container and then push it. What if I'm out to lunch and somebody discovers a big bug and they want to push a new version out? That's not CI/CD. That's not continuous. So having some kind of a CI/CD process in place that can do those steps that I just manually did in that demo file. There's only a couple commands here, right? I run Docker compose, I run tag, and then I push it. I need something that can automate that every time, ideally, that I have a change to GitHub. That's where CI/CD steps in. So we're going to push to GitHub. Whenever I think about a tool, I never like it when people try to sell me on a tool without telling me what it actually does for me. So for CI/CD, if you're a one-person shop and you are the only one doing this, probably don't need it, right? But if you're in a larger company of any size and you want to automate changes to builds and have testing builds and have production builds, it really does help to know, look, we have a consistent process to say, make my changes in GitHub, push it to a CI/CD server, let it do the build and run my tests. It'll then send it to a container registry, which then puts it to a web app in the cloud. It'd be nice to just automate that, so I just push my changes, merge my branch, and I move away from the keyboard, step off, things build, and a couple of minutes later, it's just running. Let's see if we can make this work. This is the scary part of the demo, by the way. Live, cloud-induced demos involving Azure, GitHub, and multiple third-party services. Who thinks it's going to work? I love giggles. All right, so we're going to run that same Docker file. Let's go look at it real quick. that same Docker file is going to run, but it's going to run in the cloud. And instead of running the Docker compose debug, we're going to run a Docker compose without the debug. The only real difference here is the node environment on line 8 is now production instead of development. And on line 11, we only expose our actual port. We're not exposing debugging ports anymore for security reasons. So let's go ahead and make a change. If we look at that app running in the cloud, let's go ahead and not run it locally. I've got this custom domain called secureheroes.com. You can see the app is running there, and it says our favorite heroes. Let's go back to the application. I don't know what these changes are, but we're going to revert them. Oh, I got that RxJS thing in there. We'll get rid of that. That would make it big. Let's go over and rename the title of our app from our favorite heroes to all things open heroes, like that. And we'll go over to GitHub, and we're going to say commit me. That's a great commit message, by the way. Highly recommended. And we're going to push this. Now, I think you all trust here. We've all used GitHub enough to know it's getting to GitHub. But where does it go from there? I don't know. Let's find out. So I'm using for CI/CD this tool called Visual Studio Team Services. Oh, thank you. Good afternoon to you, too. And inside of here, we can go look at our builds and releases. And I have this build queued up right here. And it said succeeded a little while ago. If we go look at the definition for this build, we can see one's now in progress right there on the bottom left, number 185. Let's see why that's the case. If we go click on edit, what happened here was when GitHub changed and saw that commit and that merge, it then said, okay, there's this thing called a trigger. I've enabled the trigger status for this build to say when you see a change in GitHub source, go ahead and run this process. Then I have 3 simple tasks. The first one is go to GitHub and get my code. Pretty easy. The second one is run Docker compose right here. That's pretty easy too. We saw what that one looked like. The last one is push to the Azure Container Registry. This is actually going to take the image that it builds inside of VSTS. This could be Jenkins or Circle CI or whatever your favorite CI system is, Travis, CodeShip. And it's going to push it to the Azure Container Registry with the image name that I'm using. Now, we can watch this build too. Let's go back to the builds. And let's click on, I think it was 85. It should still be building. Cool. 82 seconds. So while this is building here, let's think about what this is doing. It's building the container, but I have a lot of keys. I'm hitting a database. I've got keys and secrets. I'm using Twitter for OAuth login credentials. I have different keys there too. Maybe I hard-coded all this stuff in my app. No. Please tell me you don't do that either, right? Yeah. So we don't do that. But how do we handle different environment variables? Well, let's go take a look at the source code again. And let's think about what we want it to actually do. So if we look at the source and we go to the client, nothing should happen on the client for anything server-related environment variables. Everything should happen on the server. Inside there, you're going to see I've got an example file which shows us, okay, here's where our Cosmos DB credentials are going to go, our Twitter credentials, and we're going to expose them. I've got a development version, which I'm not going to click on, because every time I do that, I've got to change the keys. Those are local keys that I'll use here that I've hard-coded, and those are git ignored. Then I've got a production file. The production file is referring to environment variables for all of these keys. By doing that, this now means that all those keys are fine to check in. This file is fine to check in because it's not storing the keys. It's looking for environment variable settings, which then means in Azure somewhere I have to set these up. Well, there's 2 ways to set this up in Azure. One way is to go to Azure in the portal and do it. Another way is I like to stay inside my editor. There's this thing called the Azure App Service extension. And if we click on the subscription where we keep it, it'll go out to Azure. It'll look up all the different things that are my subscription. I should have one here called Papa Ignite Angular. If I look at the application settings, uh-oh, there's my key. Now I got to change it again. You can see there on the left, Cosmos DB, Twitter client, all these kind of keys are associated there. And I can go and I can click on these, and I can say edit the setting. It'll let me change those key values up here, Cosmos DB name, I can change my database name. So if you don't want to go to yet another place to change settings, you don't have to. It does all that right here. So I've set all these keys up. Let's go see if VSTS completed. 2.8 minutes. I love that it says 0.8. Makes me figure out how many seconds that is. And then we should be able to go to look at our public site, and we changed the title, right, on Secure Heroes. So if I refresh, it should say All Things Open Heroes. Pretty cool, huh? I like that. So everything works in a nice flow. We get things lined up so that they just run smoothly through, and I can make as many changes as I want to the process as I go through here. Now, I don't have to go through the extension to do this. The other option is I could go up to the Azure portal, and if I click on portal, let that load. Oh, you're going to ask me for my password in front of all of my friends here. We have two-factor authentication. Let's see if that works. This will be fun. Oh, cool, it was already logged in. Yeah, I planned that. So up in the Azure portal, I'm going to click on the web app, because this is another place you can set things up. In that web app, I can go down to Application Settings, and I can scroll down. You're going to see all my keys once again. So I can set them in here, or I can go back to VS Code and set them through my VS Code Azure App Service extension right there. So it's really like, which way do you want to do it? You can also use the Azure CLI if you want to type them in and put it that way. But there's options here. I kind of like to stay in my editor. Another option that I have is I also had to set up all my Docker stuff, right? So my images and containers are right here. What if I just wanted to push one directly? Well, I could take my image, I could then go to that image, and I could say, all right, run it. If I click on run, it would run another container right here locally. Well, once I have that image running, I can then push it. So if I go ahead and click on push, it's going to push it to whatever registry I set it up for. It's going to go to either Docker Hub or the Azure Container Registry. So I can do all this right with right-clicking, or I can do it through a CI/CD process. And if, by the way, if all these nuns bother you, who doesn't like nuns? We can click on this button up here. It will then prune out any in-between images. And when it's done, they will disappear like that, if you like to keep a clean slate. So we've got a nice little way of looking at this stuff, and we can also go ahead and inspect it, show the logs, etc. If we then want to go to the container, while it's green, we could then say stop the container. We can remove the container. We show how we can attach the shell. But also notice we've got registries in here. So I told you that it went to Azure's Container Registry, but how do you know it got there? One way you could do this is go back to the portal. Back on the portal, we can come up here to our dashboard. And you'll notice I've got this pop-up container registry, because everybody needs one of those. And the only thing that's in there, if we go down to repositories, is a list of all the images that I've put up there. So here we can see the image that I put. By clicking on this, you can't really tell what's there, so you have to kind of dive in, and you can see the details about what's in this particular container. So if we back out of here, one of the other interesting parts is once I set up CI, this webhook got automatically created. This webhook is what tells Azure, okay, that shouldn't be red, by the way. That's kind of dangerous. It's what tells Azure that, okay, I received a new container. Now send that container over to any app services, any web apps hosted in Azure that want this. That's how we got our new version up and running inside the cloud. It set this webhook up to point over there. So just like we have a Git hook that says VSTS goes to Git and gets the code, there's a webhook here in Azure saying, when you put something new in my registry, I'm going to go send it off to anybody who's listening and looking for this. And then if we go back to our web app, and we scroll down a little bit, there's this tab called Docker Container. If I click on that, you should see some familiar settings. There's the name of my registry, name of my image, the tag, and down at the bottom, there's that checkbox I mentioned for CI. Because I set up continuous deployment, it automatically set up that webhook to say, all right, anytime we get a new container in the registry, pull it over here. Then we can save that and move along. We can also do some of that down here by clicking on the tabs in VS Code. So down here, we can click on the registry, look at the one that I set up. Inside that registry, we can see all the different tags. This is latest right there. And I can deploy that image to the Azure App Service right from VS Code if I want to as well. Again, no CI/CD in this case. It's just I'm writing some code. I want to see if it works. Let me right-click and just publish it. Great for testing or load balancing or load test scenarios. You can also do this to public registries like Docker Hub. So in Docker Hub, I'm logged in as John Papa, and there's my Angular CLI image. So I could also deploy new ones right there as well. So again, it's nice that we've got these extensions that kind of help us move things along without having to leave our code editor. All right. So what we saw here was how we can deploy Angular to the cloud by first building and running and debugging locally with Docker. To me, this is an integral step. I hear a lot of people talk about containers and Kubernetes and Swarm and Mesosphere and all these cool big words all the time. And they are cool. They help us do a lot of amazing things. But before I look at a solution, I want to know what the problem is. Do I have the problem that this thing is solving? And am I losing anything by using this tool? Anytime somebody comes out with the next cool thing, you should automatically ask yourself those questions. What am I giving up? Is this really solving a problem that I have? How is this going to make my life better? Right? In this case, I made sure I didn't lose my development process. I wanted to make sure I could run, debug locally, do everything I could do before. Once I check that box off, I'm happy to say, okay, that's good. But is this going to enable me to do something new and different? It can't just be a better way to do the same thing I was doing. I want to know I can do something else. Now I can run the same Docker container through a CI process and continuously deploy it somewhere and make sure that I don't have to worry about, oh, geez, you know, it's running Node 6, I'm running Node 7, he's running Node 8, what's going on? And then finally, hosting it into a cloud, running on Linux. I'm running Mac OS here, maybe you're running Windows locally. If you're going to run Linux in the cloud, you can set all 3 different operating systems with confidence knowing it's going to run everywhere, again, using Docker in this process. So kind of summing things up, this is where I think a lot of the tooling's made our lives better. If you flash back to a couple of years ago with JavaScript, we didn't have a lot of these CLI type tools. We didn't have things like Docker. We were basically building all this by hand. I remember not so long ago building out a 1,000-line gulp file to make sure my build process worked right, and then debugging the heck out of it to make sure it worked under every situation. And I love gulp. I think it's awesome. But now I don't have to worry about that. I just type ng build, and things just build for me, and I know how to make my files smaller and faster. And Docker makes it run everywhere. No more stickers that says works on my machine, right? Now we can say, hey, I know that I can build this and give it to you, and it's going to work. I know with confidence that it's going to work. And that's something we haven't been able to say in a long time. And CI/CD servers make things so much easier. So we can continuously integrate with things like GitHub and run our unit tests and our end-to-end tests. And then we can use continuous deployment to deploy it to a container registry like Docker Hub or Azure Container Registry right to a cloud. And the best part of it to me is I never have to leave my Visual Studio Code editor. I can stay inside my editor of choice, write my code, I can build my project, run my Docker commands, and go deploy it to the Azure App Service right from my editor. I don't have to go to the portal for Azure. I don't have to go to my CI/CD tool. I can actually monitor everything locally, which is good for me because then I don't have to have 8 monitors up figuring out how I'm running everything. If you want to try this stuff out, here's some cool links that you can use. The top one gives you everything I showed you today. It's all the source code. It's a README file explaining the various ways that you can read this. It's so cool to watch about 100 camera phones pop up at the same time. You can grab this code, play with it. I'm thinking about writing an article on the Azure Docs that shows how to do this, or in the Angular Docs, maybe one in each, so we can share how to do this. All the extensions I showed today, you can find those up here as well, the Docker extension, Azure CLI, and even some Angular ones in there. And if you like the theme that I created that this week inside of VS Code. You can check it out. I'm a Game of Thrones fan. It's called Winter is Coming. So you can check out that. That comes with this as well. If you don't like it, that's okay too. But I want to say thank you all for coming this week, and catch me on Twitter.